We may get some postings in EEE, State Electricity Board. So that is their visualization. So that means most of us, they are aware that where the placement will be there only in the TNEB, that means now will be converted into candidate code. So that means that much awareness is there even in the public domain. So as a core engineers, electrical engineers, you should be thoroughly aware about this subject power system analysis, so that it will be more useful whenever you are going for some placements or whatever may be the thing. All over the world, lot of requirements or opportunities are there, but the requirement is the thorough knowledge in the core subjects. Suppose if you are trying some core jobs in the power sector, where you should be very thorough with these job requirements. For example, gas market openings are available for power system engineers at ABB. Just you can go through the website. But the requirements, they have specified what are the requirements as on date at ABB. Last few days where the students are applying online, and the requirements were that you should have thorough knowledge about the power system studies. If you are coming to the power system studies, the major three studies were load flow analysis, short circuit analysis, and the stability analysis. And whenever we are going for interview, where we should have thorough knowledge in the sense, whatever may be the point they are discussing, we should be able to proceed further. That is the requirement. Even one of our students, he attended an interview. So they have started the interview. They were asking about power flow analysis. Okay, immediately the next minute, they are asking him to write the power flow equation. They are able to follow. So how long you can talk that and all olden days. Nowadays, if it is a core industry, you should be very thorough. You can't say that I have not prepared. They are able to follow. So that means you should be that much flexible. You have to understand the concept, then only you can write immediately what you know. Otherwise, simply marking up for the SMS university examination, and there you may be scoring even 85 to 95 marks also, but that is immaterial. By scoring the marks, we can't do anything. It is no way useful for the actual life. So while coming to this subject, as usual, according to our syllabus, where we have 5 units. Whatever may be the subject, irrespective of the subject, we have 5 units. In that, while coming to the analysis part, the first one, introduction. So while starting the introduction, the first line in the syllabus is need for power system analysis for operation and planning studies. Planning. What is operation and what is planning? And if you look into the power system planning, one of the major example is Pudong nuclear power project. When they have started, whether you have any idea? When it was started? 1998 also they have started. Now we are at 2016. Still it is not at its full capacity. Still they are saying somewhere the unit 2 is started, it is in critical condition, it will be connected to the grid. So like that the statements are there, but it is not 10 years ahead of time. The planning of power system should take place at least some 10 years ahead of time. So the basic thing as a power system engineer, if they are asking what is the planning study in a power system, what type of planning you will do. Suppose now somebody is asking, now if you want to carry out power system planning studies, what is the sequence involved in that? Whether you have any idea? It is not much complicated. It is very, from there you have to start. But here in your syllabus, where the topic is not there, first we have to start with the load forecasting. First we have to start with the load forecasting. You have to, whenever you want to consume the power, without asking anybody's permission, simply we are turning on the switch and turning off the switches. Am I correct? Whether you are getting any permission from anyone to turn on or turn off the switches, and you know the other constraint. Is it possible to store the electric power? We can't store the electrical energy, or very rarely with the batteries we will be storing little amount. If the power is nowhere stored, but whenever you are interested, you are turning on the switches and you are consuming it. So that means whether after turning on the switches, whether they are starting any generation to supply your power or how it is matched. Whether you have any idea about that? So those details you will be studying in the next subject, that is power system operation and control. But you think it, you are able to visualize. You never thought that you know the power is not stored anywhere, but whenever you want, whether 2 AC equipment or 5 AC equipment, whatever will be the rating of your load, without getting permission from anyone, simply you are turning on the switch. You think other way, suppose you need some 1,000 rupees, whether simply if you are putting your hand anywhere you will get 1,000, it is not possible. You have to request your father or friends or somebody else to get that money. But while coming to the power, we know the problem, storage is not feasible. With that difficulty also, we are able to get the power whenever we are interested. So if it is the case where the planning of our system is one of the perennial problem. So planning in the sense, the first thing starts with the generation planning. So to start the generation planning, what we should do? We have to carry out the load forecasting. Once you have completed the load forecasting, then for the forecasted load, you have to go for generation planning. So now the question is, what is generation planning? Generation planning means for the forecasted load demand, you have to think the different types of available generations. Suppose you are an engineer, then the government will ask you, what are the possibilities to meet out the load in the year 2030? Where from the load forecasting, it is understood that 5,000 megawatt of additional generation is required in 2030. So now, what planning strategy you have? They will ask the operating personals or planning personals in the TNEB. Then, what the planning person they will do? They will conduct lot of analysis. Lot of analysis in the sense, they will assess the resources. First, they will consider hydroelectric power stations, because we have the concept of renewable resource utilization. So with that, the first priority goes to hydroelectric power. But while utilizing the hydroelectric power, lot of other difficulties are there. For example, you take Medu Dam. While considering the Medu Dam, in the electrical engineering point of view, always you will think that this much amount of water is there, so we can operate the generators for this month, these many days or these many hours. But you can't operate the generators available in the dams as you wish. You are able to follow? It is not in the electrical engineering person control. Why? Where you have to generate the power only when they are releasing the water for the purpose of irrigation or some other drinking water purpose. You are able to visualize? Whenever there is a hydroelectric power, you cannot generate the power as you wish. But some of the dedicated hydroelectric power stations with a lot of possible locations, and you have to give at least some 2 to 3 options to the government. So out of which they will select any one. And while selecting the site or the type of generators, what is the basic requirement? How to analyze whether the location is suitable or not? How to decide that? So for that purpose only, you have to carry out load flow analysis, short circuit analysis, and the stability analysis. So these are all the 3 basic studies required for the generation planning. Are you able to visualize? First we are conducting the load forecasting. So with that you know the load demand in near future after 10 years. Then after forecasting the load demand, to meet out the load demand in the future periods, you have to go for the generation planning. So generation planning means you have to select the type and the location. So to select the type and location, where you have to carry out this kind of load flow stability and short circuit analysis, so that you can check the electrical feasibility, because location not only based on the availability of coal and other things, resource. If you are connecting those generators to the grid, what are the problems will arise? What are the problems will arise? One of the immediate problem will be transmission line. One of the immediate problem will be transmission line. Because if you are locating a generating station where you don't have adequate transmission line, then you may not be able to pump the generated power to the grid. So for that purpose, after completing that generation planning, if you don't have adequate transmission line, where you have to go for transmission planning also. You are able to visualize what is the transmission planning. You can run the transmission line anywhere. It is not acceptable. One of the limitations, for example, you might have seen lot of transmission lines near to the college campus. Here, lot of transmission lines are available, and with these transmission lines, do you know how much power will be carried over? Whether any idea you have? See, these voltages may be 110 kV, 66 kV, or 400 kV of anything. So, for each transmission line, for example, if there is a single road, only one or two vehicles can go at a time. And if you are going for some other cities like Trichy or Bangalore, you can see 4 roads with 6 lanes or 4 lanes are available. So with that road facilities where we are able to drive our vehicles smoothly. So while going there, we are expecting that a lot of facilities will be there. So likewise, while coming to the generating station also, after generating the power, that power has to be carried out to the load center. If you want to take the power to the load center, where you should have the proper transmission planning. Proper transmission planning in the sense, whenever there is a requirement, we cannot erect simply the transmission lines. What type of analysis we have to do? We have to ensure that where the lines are optimally utilized. The lines are optimally utilized. What is the meaning for optimal utilization? You should not utilize the line beyond its rated capacity, and at the same time, where it should not be utilized to its underrated capacity. For example, there is a 500 megawatt transmission line. If the power handling capacity of the line is always at 100 megawatt, so the remaining 400 megawatt, and you are erecting only the 500 megawatt of transmission line, where you want to transmit the 600 megawatt of power through the line at any point of time, then it is always overloaded. So these things you have to analyze by conducting the load flow analysis. So from the name itself, in the unit 2, they are covering the power flow analysis. What is the power flow analysis? You can determine the power flowing through each and every element of the power system. What is the need for power flow analysis? What is the need for power flow analysis? We can find out the power flowing through each and every element of the power system. Why it is required? What is the need for power flow analysis? You have to find out the elements which are overloaded. Whether the transmission line is overloaded or the transformer is overloaded, whatever the equipments are overloaded. To analyze the overloading issues, you have to conduct the load flow or power flow analysis. Then, what do you want, you students? Whether you want to discuss anything? So, if you are running the power flow analysis, you can get the power flowing through each and every element of the power system. When you will do that, not when it is running. For the next 10 years after forecasting the load, after erecting the power stations, you have to add some few transmission lines. This you will not do it in a physical manner. You will do it on a paper. Then you will find out the power flowing through each transmission line. You have to do the simulation. Few methods are discussed in your syllabus, like Gauss-Seidel method and the Newton-Raphson method. So by running those programs, you will get the power flowing through each and every elements of the power system. And you have to ensure that even though if I am adding some 5000 megawatt of capacity, there is no need for additional transmission lines, additional transformers. You have to ensure. Or if it is required, then you have to find out a suitable path. And if you are adding any additional transmission line, you have to ensure that that line is optimally, effectively utilized. If it is underutilized, there is no use of it. If it is underutilized, it is no use. So always, whenever we are investing something, it should be utilized effectively. So that is called the transmission planning. So generation planning and transmission planning are the important thing for the power system engineers and to do. Any doubt with this? Whether you have any difference of opinion? Then, so the using about the power flow problem formulation and the solution methods. So from the name itself, power flow analysis means it will give you the power flowing through each and every element of the power system. That is the advantage. And the third unit, which is covering the short circuit analysis. So what is short circuit? Because it is the common name everywhere, we are utilizing that in our house everywhere. So short circuit means where we have to connect any one line to the ground, where that is the short circuit, already we are familiar. Suppose if you are connecting the phase to the ground, then that will be called as the short circuit. But while coming to the power system, we are under the generating systems. It is not covering the distribution system. If we are studying the structure of the power system, where it will be classified as generation subsystem, transmission subsystem, and the distribution subsystem. But here in our subject, where they are covering only the generation subsystem and the transmission subsystem, where they are not considering the distribution subsystem. If it is not considered, then how it is modeled here in the studies? They are considering that as a lumped load at 110 kV level, or 230 kV level, or 400 kV level. Are you able to follow? So we will not come below 110 kV level, and all the loads below 110 kV level will be lumped at that particular bus. So that's why we are considering only the transmission system and the generation system. And in detail, while going for distribution load flow analysis, where that is of different issue, we are not bothering about those things in the power system analysis. We are able to visualize. So in this subject, you will be considering only two subsystems, generation subsystem and the transmission subsystem, where the distribution subsystem will be treated as a lumped load at the terminals of the transmission subsystem. You will not consider the distribution subsystem. You will not consider each and every loads. If you are considering each and every loads at each and every feeders, then that will be the distribution system. Such kind of networks where you are not considering this entire syllabus. So you are not bothering about the distribution system power flow. You are considering the power flow in the generation and the transmission system. So here the power flow analysis will give you the power flowing through each and every element. So with that you can think whether any of the lines are overloaded or the transformers are overloaded, where that will be your requirement. Then what is the need for short circuit analysis? Why we have to carry out the short circuit analysis? And the short circuit analysis, there are different types of short circuit. Different type of short circuit in the sense, for example, if there is a open conductor, that is also a fault. But that type of fault is not analyzed in your syllabus. Here in your syllabus, they are considering two major type of fault. What is the two major type of fault? One is symmetrical or balanced fault. Balanced fault in the sense from the name itself, where the fault current flowing through all the phases will be equal. So that will be the balanced fault. So balanced fault means where the fault is occurring on all the three phases. Then the other one is unbalanced fault. Here in the unbalanced fault also, they are not considering the open conductor faults. They are considering only the line to ground faults. It may be a single line to ground fault, or between the two lines, or double line to ground. Sensing the fault, the relay will activate the circuit breaker contact so that it will isolate the fault by opening the circuit breaker contact. But during the opening or immediately after the occurrence of fault, where momentary current will flow through the circuit breaker contact. Momentary current will flow through the circuit breaker contact. What is that current? Momentary current. Why it is called as momentary current? Immediately after the occurrence of fault, whatever may be the current is flowing through the circuit breaker contacts, it will be called as momentary current. Are you able to visualize? Then other one, interrupting current. What is interrupting current? So during the interruption, fault is sensed by the relay. Then it will send the trip signal to the circuit breaker contact. So it is after the fault, the contacts will be isolated. So during the interruption means during the opening of the contact, whatever may be the current is flowing through the contacts, it will be called as the interrupting current. Where momentary current and the interrupting currents are very, very important. One of the simple example, where you may have the experience in starting the DC shunt or series motors by using the 2-point or 3-point starters. So during the starting, are you comfortable or you will find lot of difficulty? While starting the DC motors in general by using the starter, is it much easy or it is very difficult? When compared to the induction motor, if you are using starter or auto transformer type of starters, which is very easy, you will not find any difficulty. But if you are starting the DC motor, what will happen? While moving from one step to the other step, lot of spark will be there. Why? Because there you have unidirectional current. You have unidirectional current. So while braking, lot of energy will be released. Lot of energy will be released, which will be appearing as a spark. So it is difficult to handle. So likewise, during the fault, what happens? Huge current will be flowing through the circuit breaker contact. So that current you have to interrupt. So that means you have to design the circuit breaker contact such that it has to withstand momentary current. What is momentary current? Immediately after the occurrence of fault, whatever may be the current is going through the circuit breaker contact, it is called as momentary current. So your circuit breaker has to withstand that current. Then what is the next one? Interrupting current. So during the interruption, huge current may flow. With that, you have to interrupt the circuit. So circuit breaker contact has to withstand that also. Are you able to visualize these two? So to find out this momentary current and the interrupting current, where you need the short circuit analysis. Are you able to visualize? And one of the important information you will get from this short circuit analysis is short circuit capacity. What you will get? Short circuit capacity. Suppose this is one of the interview question, most important interview question is, wherever you go for a power system, they will ask, what is the significance of short circuit capacity? It has different names: fault level, short circuit capacity, short circuit MVA, all those things are of same. What is the significance of short circuit capacity? So if the short circuit capacity is greater than 10 per unit, if the short circuit capacity is greater than 10 per unit, then it is a strong system. What is that? It is a strong system. If the short circuit capacity is less than 10 per unit, then it is a weak system. What is the difference between strong system and the weak system? If it is a strong system, the voltage drop will be very minimum. If it is a strong system, what is the advantage? Voltage drop will be very minimum. If it is a weak system, where lot of voltage drops will be there. Or even you take the residential supply itself. Some of them, they will point out that we are unable to turn on our air conditioning equipment. Have you heard like that? Where we are using double booster, even then we are unable to turn on the air conditioning equipment. In some of the feeders, where such kind of voltage drop will occur. Are you able to visualize? What is the need for strong system? If it is a strong system, where the voltage drop will be very minimum. If it is a weak system, then lot of voltage drops will be there. So whenever you are connecting your house supplies or your house to some of the substation, you can inquire about the substation short circuit capacity. Are you able to visualize? If you are inquiring about the substation short circuit capacity, and if it is very good, where you can receive the power without any voltage drop or with minimal voltage drop. If you are connecting your residence to some of the substation which is having very poor short circuit capacity, then lot of voltage drops will be there. Are you able to visualize? So what are the informations we are getting from the short circuit studies? First one, circuit breaker rating. Circuit breaker rating means momentary current and the interrupting current. Then apart from that, for one of the important requirement for the planning engineers were short circuit capacity. Short circuit capacity, it will be also called as fault level or short circuit MVA, all are of same. If it is greater than 10 per unit, it is representing a strong system, or if it is less than that, we will be calling it as weak system. Strong system means what? The voltage drop will be very less. Weak system means lot of voltage drop will be there. And here, one more issue is there. So, to decide the circuit breaker rating or to calculate the short circuit capacity, where the symmetric short circuit analysis alone is sufficient. What is symmetric short circuit? Three-phase short circuit itself is sufficient. Then why we have to go for unbalanced short circuit analysis? Balanced short circuit analysis itself will give you all this information. Then if it is the case, why you want to go for unbalanced short circuit analysis? You are able to visualize where we have two major types of faults. One is symmetric short circuit analysis and another one is unsymmetric short circuit analysis. In other words, balanced faults, unbalanced faults. So from the symmetric short circuit analysis, where we can get all this information, and this symmetric short circuit is the severe one. Symmetric short circuit is the severe one. What's the meaning for severity? What's the meaning for severity with respect to the short circuit? Huge current will flow only when there is a symmetric short circuit. So that means if you are designing a circuit breaker with the symmetric short circuit current ratings, definitely it can handle the unsymmetric faults also. There is no issue with that. If it is the case, then what is the need for unsymmetric short circuit studies? While coming to the unsymmetric short circuit analysis, the three major types of fault as already I have pointed out: single line to ground fault, line to line fault, and double line to ground fault. Out of these three types of fault, one of the most frequently occurring fault, frequently means then and there that kind of faults will arise. What is that fault? That is single line to ground fault. About 65 to 75% of the fault occurring in nature will be single line to ground fault. If 100 faults are occurring, about 60 to 75, that will be our opinion. But if you are operating all the three poles, where there is a drawback, you consider, I will explain in a simple term, you consider there is a generator, transmission. Assume that there is a fault in the transmission line. So if there is a fault in the transmission line, what will be the power flowing to the load? Zero, because you are connecting your transmission line to the ground, so the voltage will be zero. If voltage is zero, power reaching the load will be zero. Now, assume that in the other way, where only a single line to ground fault occurs. If only that line alone isolated, what will be the power flowing through the load? See, for three lines, let us say, if three lines are there, some 100 megawatt is flowing. There is a single line to ground fault. So one line is isolated. Remaining two lines are connected with the source to the load. So how much power will flow? 2/3 of 100 megawatts. So 66.67 megawatt will flow to the load. You are able to follow? So we can restore the partial power to the loads. You are able to visualize? But there is a specific advantage while coming to the interconnected power system. Just I am saying this with respect to a single generator and load. But while coming to the interconnected power system, we are not having only such kind of single generator and load. In general, while coming to the last part, that is the stability analysis, where these kind of single pole switchings are very, very important. You are able to visualize? And the other one is relay coordination. So far we have discussed about the designing of circuit breakers based on the momentary current, interrupting current, and the short circuit capacity, all those things. So from the name itself, whenever there is some particular fault, the neighboring relays to detect that fault and it has to isolate the faulty part. So that is the concept of relay coordination. So while coming to these kind of single pole switching, where the relay coordinations are very, very important. So that's why in addition to the symmetric short circuit analysis, where we are considering the unsymmetric short circuit analysis also. But there is one of the faults. So from the name itself, you are aware, if it is a balanced system, you can go for the per phase analysis. What is the advantage of balanced system? You have to go for three-phase analysis. But three-phase analysis means calculations are extremely difficult. But for that purpose, where there is one more other additional advantage with the symmetrical components. You might have even studied in the circuit theory, symmetrical component transformation. Symmetrical component transformation means where we will convert this three-phase RYB into three type of balanced systems: positive sequence, negative sequence, and zero sequence. We are able to visualize what is the major requirement here in the unbalanced fault? Symmetrical components. What is the need for symmetrical components? If you have an unbalanced system, you have to carry out three-phase calculations. It is difficult. So if it is difficult, what we will do? We will be using the symmetrical components. If you are using symmetrical components for the unbalanced system, what is the advantage? It will resolve this three-phase unbalanced system. It will resolve three-phase unbalanced system into three balanced system. What is that three balanced system? Positive sequence, negative sequence, and zero sequence. So if you are able to resolve this unbalanced system into balanced system, then you can proceed the calculations like the per phase calculation. You are able to visualize. So while coming to the unbalanced fault analysis, you cannot carry out the calculations as such on the single phase basis, which will be considered for the three phase balanced fault. But in case of unbalanced fault, what we have to do? We have to use the symmetrical component transformation. What is the advantage? Which will convert this unbalanced three-phase system into three balanced systems. What are the three balanced systems? Positive sequence, negative sequence, and zero sequence. And so once again, if you are converting to balanced system, you can carry out the calculations on the per phase basis. And the last unit is the stability analysis. Here they are introducing about two major types of stability. One is rotor angle stability, which already you might have studied thoroughly in the electrical machines. The other one is voltage stability, where voltage stability only for classification purpose they have introduced. It may be covered only in the 2 mark questions, where they may not be covering any topics about the voltage stability. So what is voltage stability? The definition for voltage stability is, it is the ability of the power system to maintain the voltage at a rated value or near rated value. So what is voltage stability? Definition is much easy. From the name itself you can come to the definition of voltage stability. What is voltage stability? It is the ability of the power system to maintain the bus voltage at or near the rated value. Near the rated value means where normally we used to consider V minimum and V maximum about 0.95 per unit to 1.05 per unit. If you are able to maintain the voltage within the limits, then the system is voltage stable. If there is a progressive decline in voltage, at one or more buses in the power system, then it is called as voltage instability. Only these 2 more questions will be covered with respect to the voltage stability. So what is voltage stability? It is the ability of the power system to maintain the voltage at or near rated value. Normally we will consider minimum voltage of some 0.95 per unit, maximum 1.05 per unit. Then if it is the case, what is voltage instability? If there is a progressive decline in voltage at one or more number of buses in the power system, then it will be called as voltage instability. And beyond that, there is no discussion for that voltage stability in your syllabus, because the rest of the contents were covering about the rotor angle stability. Rest of the contents are covering about the rotor angle stability. So first we will understand what is rotor angle stability. Even in your electrical machines, while studying the synchronous machine, where you will be studying about the rotor angle delta, all those things. So while coming to the power system, what is the significance of the rotor angle and the rotor angle stability? As already you are aware about the steady state stability. There are 2 types of stability. One is steady state stability, other one is transient stability. steady state stability is sometimes called as small signal stability. Steady state stability is sometimes called as small signal stability. So what is steady state stability? Even in the electrical machines where the same definition is there. If you are loading the machines, gradually, until delta equal to 90, where the power output will increase. If you are loading the machine beyond that, what will happen? The system will become unstable. What will happen to the machine? Until 90, it will increase the power output. Beyond 90, if you are loading the machine, where the system will become unstable. Or for example, you are carrying a basket. What you are doing? You are carrying a basket. Somebody is adding some 100 gram weight every minute. Whether you will feel anything while adding 100 grams, assume that you are not looking into the basket. Somebody is adding only 100 grams. Or as you, who is saying yes? If somebody you add some 10 grams, you are able to follow. If you are feeling 100 gram weight, then you add lesser than that. Okay? So how long the person can add that 10 gram weight or 100 gram weight? How long it is possible? Where he may have some capacity, let us say some 40 kg or 50 kg may be his capacity. So until his capacity of some 40 kg or 50 kg, see, while somebody is discussing with you, you please listen. If you are discussing among yourself, then why I should talk something? So you are carrying a basket, somebody is adding some 10 gram weight for every minute, where the load will be keep on increasing. After some time, what will happen? Where the load will reach maximum, beyond which, even if he is adding some 10 grams, what will happen? You will collapse. You cannot hold that beyond that point. You are able to follow? So like that, for generator also, when it is running at no load, what will be the rotor angle delta? What is the rotor angle delta at no load condition? 0. If the load increases, then power output has to be increased. It is small signal stability or steady state stability. But here in your syllabus, they have not covered the analysis of small signal or steady state stability. They have covered the other part, it is transient stability. So what is transient stability? The difference is, while coming to the transient stability, where we have to consider a large disturbance. You come to the previous scenario, you are carrying a basket. What is the addition of weight? Only 10 grams. Suddenly, if somebody is throwing some 5 kg weight, then that will be considered as the transient disturbance. So in this power system also, the transient disturbance in the sense where we will consider like a short circuit on a transmission line or some loss of generator. So these things will be considered as a transient disturbance. So under transient condition, what is the stability issue? For example, you are carrying some 5 kg weight in a basket. Somebody is suddenly throwing some 10 kg. Whether you can withstand it, that depends on your inertia. Am I correct? So likewise, for generator also, we have a huge rotor mass with inertia constant h. For generator also, we have a huge rotor mass with inertia constant h. So if such kind of sudden disturbance is coming into picture based on the inertia, where it may be in stable position or it may cross that 90 degree and it will become unstable. You are able to visualize? So what is the difference between steady state stability and the transient stability? The first thing, disturbance. In the steady state stability, we are considering only a small and gradually varying type of loads. In the steady state stability analysis, what type of disturbance we are considering? Small and gradually varying type of disturbance. What is the small and gradually varying type of disturbance? Yourself. Something you are always telling. What's your name? You told something about small and gradually varying type of disturbance. Can you tell me? So small and gradually varying type of load means which is the See, you listen here, I don't know something I am discussing with him because he is making some problem. And all other students also you are joining with him. What is the reason? See, once again he is laughing. See, try to understand. See, if you are coming to the small disturbances like the routine load changes, which will be considered for small signal stability. That's why I told you, if you are observing the load curve, so load curve means which will be giving the variation of load with respect to time. It may be a daily load curve, monthly load curve or annual load curve. So if you look into that load curve, even though sudden variations are in the load in each and every location, while accumulating those loads at the substation, it is very smooth and gradual, where there is no stepwise variations in the load. For example, if you are drawing the load curve for this particular seminar hall, how will be the load curve? What is your idea? If I am asking you to draw the load curve for today, for this seminar hall, how will be the load curve? What is your imagination? It will be of some rectangular pulse. Why? Where the hall is used only between some 2 to 3:30. Only 1.5 hour we are using. And during this 1.5 hour, where we have some constant connected equipment, let us say if it is some 3 kilowatt or some 5 kilowatt. So initially, while entering into this room, all the switches of some 5 kilowatt is turned on, and while leaving, it is turned off. So the rest of the time it is zero. Rest of the time it is zero. Only during this 1.5 hour, where it is here, it is having a rectangular pulse. You are able to visualize. But if you look into the load curve, what it is available in your textbook, it will not be like that. It will be of smooth and gradually varying type. So such kind of things will be considered as a small disturbances. And with that, you have to analyze the small signal stability. But what the syllabus it is covered in your content, it is covering the transient stability. So transient stability means you have to consider the large disturbance. You have to consider the large disturbance. What are the large disturbance in power system? One of the major disturbance will be the short circuit on the transmission line, which is the major disturbance. So only with that major disturbance, where they are using the two different methods to analyze the transient stability. One of the method is equal area criterion. One of the method is equal area criterion. Equal area criterion in the sense where you consider this as a shaft. This is the shaft. Assume that you are rotating this shaft at some 1500 rpm. You are rotating this shaft at what rpm? 1500 rpm. So there is a mechanical load. Some 100 kg weight is there, and with that you are rotating it at 1500 rpm. And initially the delta will be constant. Somebody suddenly removes that load for a fraction of a second, and once again they are adding that 100 kg. So what will happen to the speed? After removing the load, what will happen to the speed? Speed will increase because you are removing the load. Same input is given, the speed will increase. Then once again it is added, then the speed will decrease. So why the speed is increasing? Because of the increased kinetic energy. Why the speed is once again decreasing? Because the load consumes the stored kinetic energy in the rotor. So only based on these two concepts, where you have to analyze the variation of rotor angle. You have to analyze the variation of rotor angle. What is that variation of rotor angle? Like load curve. Already you are familiar with the load curve. What is there in the x-axis of the load curve? You might have plotted the load curve. What is there in the x-axis of the load curve? Power. Load curve, last semester TND you might have studied. The x-axis where there will be time will be there. You are able to visualize. So you will be plotting the variation of load demand with respect to time, which is called as load curve. While coming for the transient stability analysis, similar to that, you have to plot the swing curve. What is swing curve? Which will be giving the variation of rotor angle with respect to time. Which will be giving the variation of rotor angle with respect to time. So if you are plotting the swing curve, you can monitor the swing curve with respect to time, and if the delta exceeds 180 degree, If the delta is, load angle is exceeding 180 degree, then the system is termed as unstable. If it is less than 180, then the system is stable. Can you visualize? For the purpose of transient stability analysis, what we should do? We have to plot the swing curve. We have to plot the swing curve. What is swing curve? Which will give you the variation of rotor angle with respect to time. And by observing the swing curve, what will be your inference? If it is less than 180 degree, then you can say the power system is stable. If it is exceeding 180 degree, then it is unstable. Then in your syllabus, they have added one more other simple method. So what process we have to do for analyzing the stability is, we have to plot the swing curve and we have to analyze the stability. But one of the simple method is there, which will be useful for single machine infinite bus system or two machine system. If you have only two generators in your system, then you can use one of the simplest method, which is called as equal area criterion. Because while coming to the swing curve, you have to go for numerical integration technique. Why we have to go for numerical integration technique? The swinging of the rotor will be analyzed by using the swing equation. Even in many of the questions, it will be covered under the 2-mark question. What is swing equation? It is a differential equation which will be describing the swinging of rotor. In most of the time, even in the 16-mark question, they have covered the derivation of swing equation. Because that chapter, stability analysis is little bit difficult for the undergraduate students, so they used to cover 16-mark. If you have that swing equation, what you can do? By integrating that, by using the numerical integration technique, I think there are two techniques covered in your syllabus. One of the famous one is modified Euler method, and another one is Rangaputta method. By using these two methods, where you can find out what is the significance of studying each and every unit. So once if you have those things in mind, then while studying the topics, you can understand, you can realize why I am studying these topics, what is the necessity. So then only where you can memorize some of the concept for the future use. Otherwise, once if you are completing the examination, then afterwards you may not know what is power flow analysis, what is substitute analysis, or what is stability analysis. Any doubt with this specific topics in any of the unit? Schooling. How many of you studied in the government schools? Please raise your hand. So maybe some 10%. So 10% of the students alone studied in the government school. So that means from this, what is our conclusion, inference? What should be the inference? So that means better faculty members are available in the private schools than the government school. Is it correct? It is not at all possible, because all the toppers will be getting the placements in the government school. Those who are not getting the placements in the government school alone will be working as the teachers in the private school, except very few private schools where they used to pay huge money for the faculty members. So they will opt for the such kind of school. But most of the private schools, where they may pay some 1/3 or half of the salary when compared to the government school teachers. But irrespective of that, we are interested only in the private schools. So this problem arises worldwide, not here in our state. This was the problem all over the world. So what they did, so if you have a government organized power system, then it is very difficult to run the power system in an efficient manner. What is the problem? It is very difficult to run the power system in the efficient manner. You visit any private offices, it will be of neat and clean. If you visit any government offices, then it will be very dirty. So what is the reason? The efficiency. That doesn't mean that there will not be any sweeper for that. Where the sweepers will be appointed for that, but he will not carry out his duties, because there is no proper monitoring and control. So to avoid these things, where all over the world they have moved to the restructured power system. Restructured power system means where in the vertically integrated system, everything, all the generators are owned by the government agencies. Government organization will generate the entire power and it will transmit all the powers to the load center. Then it will distribute. What's your problem? You too. You are studying something there? Yourself. So what topic I am discussing now? Please stand up and come here. Let us see. What's your idea? So what is a restructured power system? With the government, they are unable to run the power system in an effective manner. Effective or they are unable to improve the efficiency. So what they did, they went for privatization. So how to participate the private owners in this power system. So for that purpose only, they brought the rules under the name of restructured power system. In the vertically integrated system, which is the old one, where all the generators, transmission system, and the distribution system, all are controlled by the government. But now with the restructured power system, where they are encouraging the private owners to participate in this system. Private owners in the sense where you can generate power or you can contribute for the transmission or you can contribute for the distribution and with that you can earn profit. So that is the logic. One of the simplest one, so if you are considering the generation sector, you can add some generating stations and first definition for the restructured power to GENCOs, TRANSCOs and DISCO. What is GENCO? Generating companies, transmission companies and distribution market players, encouraging the competition among the private market players. But even the restructured power system where there is a non-profit organization which is called as ISO, Independent System Operator. Independent System Operator will monitor the entire system. Independent System Operator will monitor the entire system. But the private players can generate power and they can sell power. You are able to follow because power system is one of the most complex one in the world. You can't find any other complex system than the power system. You are able to visualize which is one of the complex system in the world. The only thing is power system. Why it is so complex? Why it is so complex? Because no one aware about the available demand. No one aware about the available demand. But minute by minute, the demand requirement is satisfied by generating suitable amount of power. You are able to follow? No one in the world will forecast or they cannot measure accurately the demand requirement and the transmission system losses. Without knowing these two things, where the operator will generate to solve that. Even the problems also, not a simple one step or single step problems. Each problem where it may take some 20 minutes, 30 minutes time to solve it. But in the unit one of the simplest problem you may have, there is the per unit calculations, and in most of the questions where the problem was repeated. Per unit calculations are much easier. By using those per unit calculation, where you have to conduct another outflow program or short circuit studies or stability studies. So quickly, I will recollect the other topics in the unit 1. One of the other major topic in the unit 1 is component modeling, because where you are going for outflow studies, short circuit studies and then stability studies. For that, you have to model the components. What are the component modeling covered in your syllabus? First unit. Modeling of components. What are the components for 3 different types of studies? Generator, transformers, transmission lines and loads. So only these topics. Have you studied these topics in your syllabus? These topics alone I will discuss. If you have any queries, we will discuss those topics. Because sometimes even the modeling of these components can be covered in the 16 mark question. So this modeling is much more easier. You please listen, and if you have any doubt, we will discuss then. Component where generator, transformer, transmission lines, bus bar, everything is represented with a symbol. What is the advantage? Normally they are starting with the three-phase representation. So with thousands of buses, which is much more complex to identify anything in the circuit. Then based on the balanced system of operation, we came to the per phase representation. To eliminate the neutrals involved in the single phase circuits, where we are moving to the single line diagram. Have you studied in that order or not? Three phase is the actual circuit. If you are representing the actual circuit on a paper, you can't trace anything in the three phase circuits. You can't analyze the three phase circuit diagrams. It is much more difficult. So with the concept of balanced system, where we move to the single phase representation. Even in the single phase representation, where the neutral is involved. So if you want to eliminate the neutral, then you have to go for the single line diagram. And while coming to the component modeling, where this is not mostly it is not covered in part B, but this is the basics for all the remaining 3 units: load, flow, short circuit, and stability. So the components were generator, load, transmission line, transformers, and the shunt elements. Go to the next one. Next. Please. The first thing where we will consider the transmission line. Next we will go to the generator. While studying the transmission lines, like transmission and distribution, you might have studied about the classification based on the distance. If it is less than some 50 to 80 kilometers, it will be called as short transmission line. If it is between 50 to 82 up to 240, it will be considered as medium transmission line. Beyond that, it will be called as long transmission line. So while coming to the power system, first we will start with the long transmission lines, how it is modeled in the power flow analysis, and medium transmission line, then short transmission line. So here, what is the concept of component modeling? How to represent transmission line in the load flow or power flow analysis, short circuit analysis, and the stability analysis. And here, as you know, it shunt admittance. Actually, we are not having any connections between the line to the ground, but where the air is acting as the medium, which will be acting as the insulators for the capacitor. So while coming to the shunt elements, it is only the line to ground capacitance or between the line to line. Go to the next. And this is the lumped circuit equivalent. While studying the voltage regulation for the transmission line in the T&D, you might have derived the two types of equivalent circuits for the transmission lines. One is pi equivalent, other one is T equivalent. Normally in the power system analysis, we are not considering the T equivalent, because if you are going for the calculations where the number of nodes were increasing, and with that the calculation should be a little bit difficult. So normally for the simplification purpose, we are using only the pi equivalent circuit or pi model of the transmission line. Please. So here you can see pi model means where the series impedance is represented by the Z prime and the shunt admittance were Y prime by 2. And if you are going for that lumped circuit equivalent derivation, you will get the expression for Z prime and Y prime. So these are all the expression for Z prime sin H gamma L, where the Z represents the series impedance of the line per unit length. And similarly, next, while coming to the shunt admittance, where that the Y represents the admittance per unit length. So while multiplying that by the total length, you get the total admittance. Next. Please. While coming to the long transmission line, which is reported in the previous diagram with series impedance and the shunt admittance Z prime and Y prime by 2, what it is given by the expression, you have to use those admittance and the impedance. Then while coming to the next category, medium transmission line. Medium transmission line means where the line Medium transmission line means where the line length will be 80 km to 240 km. So if the line length is within that, where we have to modify some small thing with the already existing equivalent circuit. So while representing the transmission line, in case of medium transmission line, instead of Z prime we will use Z, Y prime we will use Y. What is that Z and Y? Z and Y is nothing but the total series impedance and shunt admittance of the transmission line. Next slide. Transmission line less than 80 kilometers, we will not consider the shunt element. We will not consider the shunt element. We will consider only the series impedance in case of short transmission line. So, in case of transmission line, you have to consider the classifications based on the three types: long transmission lines, medium, short. If it is long transmission line, lumped pi equivalent circuit you have to use. Then medium, so instead of for that Y prime and Z prime, you have to use simply the total series impedance and the shunt admittance. Then if it is short transmission line, you have to eliminate the shunt admittances. So with that representation, you can carry out load flow analysis, short circuit analysis and stability analysis. But while coming to the practical applications, these models were used only for load flow and short circuit analysis. These models were used only for load flow and stability analysis. These three type of models what we have discussed for long, medium and short transmission line are used for load flow and stability analysis. But when coming to the short circuit analysis, by considering the magnitude of short circuit currents, where we are making some simplifying assumptions. And with that, in the short circuit analysis, whatever may be the type of transmission lines, we will consider only the series reactance. Are you able to follow? Series reactance means only the line reactance X. You will not consider the resistance, you will not consider the shunt admittances. Next. Yeah. You can see here, while coming to the short circuit analysis, what we are doing, you can see the assumption. The first one, shunt admittances are neglected and series resistance are neglected. So, if you want to represent, suppose if somebody is asking, model the transmission line for short circuit analysis, what should be your answer? You have to take only the series reactance of the line and you have to specify the analysis for the purpose of transmission. Next one is the transformer. So when coming to the transformer here, once again we will neglect the shunt admittance, that is JXM, magnetizing reactance will be neglected. And here if it is load flow and stability studies, we will consider this R1 plus JX1 as well as R2 plus JX2. If it is short circuit studies, once again you will neglect the resistance also. You will neglect the resistance also. And already you might have studied the per unit representation of the transformer. So what is the advantage of the per unit representation? What is the major advantage of the per unit representation in the power system analysis? Main advantage, the ideal transformers will be removed from the system. What is the advantage? Then you will transmit and you may step down to 66 kV or whatever may be the thing. So whenever there is a transformer where you will step up or step down the voltage, and on the reverse side the current will be stepped down or it may be stepped up. So the calculations are extremely difficult. But if you are introducing the per unit calculation, what is the advantage? The ideal transformer, go to the previous slide. The ideal transformer, that N1 is to N2 and the nearby is represented as ideal. So that will be eliminated. Directly you can connect it. You are able to follow that portion will be eliminated. But when you can eliminate that, only while representing that impedances are in per unit value. For different types of studies, load flow, short circuit and stability, we are using different models. The first one is load flow analysis. In load flow analysis, where the generator is simply represented by a power injection model. How we are representing the load flow analysis? Power injection model. Go to the next slide. You can see the representation of a generator in the power flow analysis. So this is the actual scenario: generator, and it is connected to a step-up transformer. Then it is connected to the transmission line. How this is represented in the load flow analysis? We used to neglect the step-up transformers at the generating station. Whatever may be the load flow analysis problems you will be solving, you will not consider the transformers at the generating station. Are you able to follow? You will not consider the transformers at the generating station for the load flow analysis. So we are eliminating the transformer. Next, what we are doing? Under that generator, how we are representing? In this load flow, we are representing it as a complex power injection. What is the complex power injection? PG plus J QG, real power and reactive power. So how we are modeling the generator for power flow studies? It is modeled as the complex power injection, PG plus J QG. So real power and reactive power. Are you able to visualize? The next, short circuit analysis. So we are coming to the generator equivalent, where the voltage source behind the impedance. You might have studied this equivalent in your electrical machines itself. And in short circuit analysis, where the resistance RA is neglected. Normally in the short circuit analysis, all the resistance, series resistance will be neglected. So that's why here we are not considering the series resistance of the generator. And the other side, parallel equivalent of the transformer, only a series impedance. It is short circuit analysis, so we are neglecting the resistance also. So step-up transformer reactance along with the generator. So how we are representing the generator here? Voltage source behind the reactance. Here we are coming to the generator reactance. Depending on the state, whether it is under subtransient condition or transient condition or steady state, you have to use suitable reactance. You have to use suitable reactance. Suppose if you are interested in subtransient current, you have to use the subtransient reactance, X double prime. The double prime represents what? Subtransient condition. Suppose if you are interested in transient condition, you have to use X prime, that is the transient reactance. If you are interested in steady state, you have to use the X. You are able to follow? After the occurrence of fault, the first thing will be the subtransient period. Large oscillations will be there. Subtransient period. Then followed by subtransient period, transient period will come. Followed by the transient period, steady state will be there. Steady state means where there are not any variations in the variables, current or voltage. So this is the model used for generator resistance also considered. The other one, loads. So while coming to the power flow analysis, once again the loads are treated as the complex quantities like PD plus J, QD. How we are considering the generation in the similar manner, the loads will be represented as the complex power drawn at the load bus. Generators are modeled as complex power injection. Loads are modeled as complex power drawn at the load bus. PD plus J, QD. So in this way we will represent the load in the power flow analysis. So how to represent the load in the short circuit analysis? So in the short circuit analysis, when compared to the short circuit current, the magnitude of short circuit current will be much higher than that of the load current. So with the simple assumption, we used to neglect the load current by comparing with the short circuit current. So how you are representing the loads in the short circuit analysis? How you are representing? Loads are neglected. Why it is neglected? When comparing with the short circuit current, load currents are negligible. So we are not considering the loads in the short circuit analysis. Next, the stability analysis, where the loads are represented as constant admittances. Loads are represented by constant admittance. But already we are familiar, complex power equal to root 3 VA in case of 3-phase. So whatever may be the complex power, that will be represented by a constant admittance. So with the given voltage, you have to convert that power. The first one is complex power drawn at the load bus, PD plus JQD in the load flow analysis. Next, loads are neglected in the short circuit analysis. Then the last one, constant admittance. What is constant admittance? We know S complex for S equal to Bi conjugate if it is P plus JQ, or P minus JQ means B conjugate I. So with that where we are getting the admittance as PD minus JQD by Z plus voltage is for that. So I think these are the 3-4 major components: transmission line, transformer, generator and load. If you are able to visualize anything, because this is one of the important topic where these models will be used for all the types of studies, and whenever you are using it you can recollect these things. The other per unit calculations, which is much more simple, because only the standard definition of actual quantity in the unit divided by base quantity in the same unit will give you the per unit quantities. The advantages of the per unit quantity: the major one is elimination of the ideal transformers from the circuit. What is the major advantage? You never calculated with the ideal transformers, because if you have hundreds of ideal transformers, you will get a lot of confusion, it will take a lot of time. So if you are going for per unit representation, ideal transformers will be removed from the circuit, simply the series impedance will be mentioned in the circuit. The other one, when going for three-phase analysis, we will multiply the quantities by √3, and per phase it is not required. So such confusion also will be avoided if you are using the per unit analysis. And these two are the major thing. The other one, visualization. One of the example I will show you. Go to the next of all the units. The advantage is always where you have to come forward what is there in these 5 units, why you have to study these things, what is the importance of these things with respect to the practical significance. So that should be your question whenever you are studying any subject. So that's why they are giving the highlights of all the topics covered in unit 5. So now we are at the end of this session. So you have the other opportunity, because where you will be studying all the 5 units in detail. If you have any specific doubt with respect to any of the topics in the power system analysis, you can raise your queries. We will discuss. Any queries?